Welcome to Migration Best Practices, a part of the Google Ads API Workshops 2021. My name is Tanit Pranarath. I am working as a developer relations engineer based in Tokyo. Before we start, please be reminded that we have a Q&A forum located below this video. Our team is standing by to answer any of your questions. Feel free to submit any questions and avoid the interesting questions you find. This is the agenda for this talk. I will cover three main topics today. Efficient data retrieval, where I will explain the situations where each of the data retrieval methods are suitable for. Efficient mutate, where I'll discuss how we can perform mutate in the Google Ads API efficiently using several features offered by the API. And finally, excelling at Google Ads query language queries or GOQ queries, where I'll delve into the language, segmentation, and some special rules for the GOQ queries. Let's get started. The first topic is efficient data retrieval. In the Google Ads API, we can use data retrieval for many use cases, just as when you want to download the properties of your entities together with some metrics, or when you want to do some reporting of historical statistics, where that can return you a lot of rows, or when you want to do the local syncing, where you might want to download all the information for your given accounts and store it as a local copy in your databases so that you can use that with your applications to run faster. One of the good things of the Google Ads API is that you can use the same interface for all the use cases I mentioned. In the Google Ads API, we have three methods for data retrieval: search stream, search, and get. Search stream allows you to retrieve information for unlimited rows with a single request, and it is most efficient method of the Google Ads API. So you should use this by default, and it is particularly useful for large downloads, except for some situations that you might want to use search method instead. And before going to talk about the scenarios where search is better than search stream, let's take a look at some details of search. Search method retrieves information one page at a time, and you should always set the page size to be 10,000, which is the maximum size of page, unless you are severely memory constrained. Our client libraries handle pagination automatically for you, except if you want to go backwards. If you use the REST API, however, you need to handle pagination by yourself. The common scenarios to use search or paging is first when you have unstable connection. Imagine that you are downloading 100,000 rows using search stream and your connection keeps breaking. Then in this case, you need to start from the beginning again and you would never get your whole results. But if you use search in this case, you can just retry only the pages that the connection failed. The other scenario is when you want to go backward, like when you're creating a UI providing the previous and the next buttons for your users to navigate back and forward, and you cannot store all the results in your memory. Then when you use search, you can just download the results or the rows that are needed in a particular page by using the next page token. And I will talk about this later, very soon. Let's take a look at the simplified Google Ads API architecture related to search. When you issue a search request to the Google Ads API, it will fetch the result from the database for you and will store the result at the cache layer. After that, it will return the result to you. For subsequent pages, when you issue a search request with the next page token, it will go directly to the cache layer without going through the database again. So in this way, you will get the result faster. However, note that the page tokens will live only for 2 hours, so don't get too long to get all your data. Having said that, if a page is demanded, the timer gets reset. Let's see how we can use the search method to go backward. As I mentioned before, our client libraries handle the pagination automatically for you, but only for going forward. If you want to go backwards, you need to do the following. First, you need to store the data of the first page, because we don't have the next page token to refer to. For the subsequent pages, you need to keep track of all the next page tokens. When you send a request to the search method of the Google Ads API, it will return you two things. First, a number of rows of the page that you just requested, and the next page token. For example, if you request the page number 2, you will get the rows number 10,001 to 20,000 and the next page token as T3 for the third page. You just need to store all the tokens here. Using that information, let's see the example of using search to go backwards. Says you are downloading row 25,000 of the page 3 and suddenly you need to row 15,000 in page 2. What you need to do is first store the next page token for T4, which is the next page token of the page 4. Then you can go back by issue a search request specifying the next page token as T2. In this way, you will get back the result of page 2 with the row 15,000 that you want. After you are done with the row 15,000, then you can resume your operation by issuing another search request specifying the next page token to T4. And in this way, you will get back the page 4 and continue your job. The third type of data retrieval method in Google Ads API is GET. GET is specific to one service. It is a very expensive operation because it will retrieve all the properties of the specified entity. And some entities in the Google Ads API are very complex, consisting of dozens of properties. And that's why you should not use that in production. Limit the usage of GET to only for development or debugging purposes. Let's recap. We have three types of data retrieval in the Google Ads API: search stream, search, and GET. By default, you should use search stream in most scenarios. But for some special circumstances, like you are very memory constrained or you are creating a UI that retrieving data in pages makes more sense, then you should use search. And you should specify the page size to 10,000 unless you have a memory constraint. For GET, use this method only for debugging and testing only. We are limiting this GET method to 1,000 requests per day, and it will retrieve only one row for one object. For search stream and search, you need to specify the fields or the columns in your query explicitly, but for GET, it will just retrieve all the columns or the fields. So the bottom line for the data retrieval here is to retrieve information, use search stream by default. Next is about catching metrics. The Google Ads UI and the Google Ads API share the same infrastructure for account statistics or metrics, and the calculation of the metrics like clicks and conversions are delayed by around less than 3 hours. However, some metrics require more time and are only calculated once per day. The best practices here are that, first, you do not need to retrieve metrics more frequently than they are calculated, because that would waste your time and resources. And the other one is to catch the metrics using the data freshness guidelines that we'll link on the slide here. About the CSV, the legacy AdWords API provided report download in several CSV formats, but the Google Ads API reports do not provide that, but actually are more advanced in the way that the Google Ads API return the data as a full mutable objects as per above, rather than exported text. And this is particularly useful when you want to modify the returned objects further, because the full object hierarchy is preserved. So you will not suffer from duplication of columns or normalization of the flattened CSV file. However, note that exporting from protobuf to JSON would result in a larger size than the equivalent gzip CSV, so please exporting the properties that you really want. And that's all for the efficient data retrieval. The next topic is efficient mutate. To recap the three mutate method types in the Google Ads API, let's take a look at this table. It is the same table I presented in the simple model for mutate session, so please check it out if you have not watched it yet. We have three types here: single resource, multi-resources, and batch processing. The single resource mutate type is very similar to the AdWords API in a way that it is available in most services like campaign service, ad group service, and so on and so forth. Multi-resource mutate type here is new to the Google Ads API, and you can use this mutate method type by using the Google Ads service.mutate method. For the limitation between single resource and multi-resource mutate types, they are very similar, except for that the multi-resource mutate type allow you to mix several entity types or resource types together. However, not all the resource types are supported in the multi-resource mutate type. Finally, batch processing. This is also similar to the AdWords API, but the underlying mechanisms are different. The batch processing can be done via the batch job service, and it allows up to 1 million operations. It can also mix resource types like the multi-resource mutate type does. The timeout is unlimited because it is a asynchronous connection. So this is suitable for large processing and concurrent jobs. The error is semi-automatically handled, especially for the transient errors on the server side. Let's take a look at the anatomy of a mutate in a single resource service versus Google Ads service. For a single resource service, I use campaign service as an example. In the middle, we have campaign service.mutate campaigns as the method that we want to send a request to. As an input, the mutate campaigns request object contains operations, which in turn is a list of campaign operations. In each campaign operation object, there is a one-off field which can be either of create, update, or remove, meaning that we can mix the operations together in one request. You may send 2 create operations, 3 update operations, and 1 remove operation together, for example. And once the request reaches the Google Ads API, it will process your request and then return a result to you, which for the campaign service.mutate campaigns, the output is the mutate campaign's response, which in turn contains the results variable. The results variable is a list of mutate campaign result objects, which has one-to-one correspondence with the operations that you sent. For example, operation 1, if you send create operation to the server, then the mutate campaign result 1 will contain the resource name of the created campaigns. Likewise, if you send the update in the campaign operation number 2, then the mutate campaign result number 2 will contain the resource name of the updated campaign as well. And that is the basic usage of the mutate campaigns. Note that we have another variable or field that I have not mentioned yet in the mutate campaigns request. It is response content type. The response content type determines whether the second field of the mutate campaign result will be returned or populated or not. When you specify the response content type to resource name only, or you do not specify the response content type at all, or the default behavior, the campaign field of the mutate campaign result will not be populated. On the other hand, if you specify this response content type field as mutable resource, then the campaign field will be populated with the fields that you modified, created, or updated, and the resource name will also be populated too. As for the anatomy of a mutate in the Google Ads service, this is similar to a single resource service with subtle differences. In the middle, again, we have a mutate method as the method that we want to send a request to. Here, the input is mutate Google Ads request consisting of multiple objects of mutate operations. And each mutate operation, there is a one-off field which can be either of ad group app operation, ad group operation, campaign operation, and so on and so forth. And as you might be able to guess, this contains a list of operations of the resource types that the Google Ads Service.mutate supports. And this is similar to a single resource service in that there is a one-one correspondence between the operations that you sent and the mutate operation responses that you will get. For example, if you send mutate operation number 1 with ad group app operation, then mutate operation response number 1 will have mutate ad group app result populated too. Or if you send campaign operation as mutate operation number 2, you will get back mutate campaign result populated in the mutate operation response number 2 as well. Next is about grouping operations. In general, grouping operations in a small number of requests is much more efficient. For example, sending 10 requests with 5,000 operations is better than sending 50,000 requests with 1 operation each. This is because it saves the network traffic for us. However, sending the grouped operations together in one request might have a problem because it can fail altogether when one of the operations failed. If in your scenario you don't want that kind of behavior, you can use the partial failure mode, which is available in many services, to help ungroup operations and allow some to fail and others to succeed. Some features like conversion uploads require backend processing, and your request may succeed but the backend process may fail later on. Therefore, we cannot say that Google Ads API requests are atomic. They are not in some cases. Let's see how we can prevent orphaned resources using Google Ads Service.mutate. Provided that we have a scenario of creating an app ad campaign, which is available as a code example in our client libraries as well, it requires many steps here, such as creating a budget, creating a campaign, setting campaign targeting, creating an ad group, and finally, creating an app ad. What if a step fails? Like when you're trying to create a campaign, it fails. Then you will be left with an orphaned budget. How can we handle this issue gracefully? The answer is to use the Google Ads Service.mutate to prevent the orphaned resources. When we use the Google Ads Service.mutate, all the operations will succeed or fail altogether, and we will have only one error status to check for the set of related operations. This will result in a fewer number of requests, which should be more efficient for you. To use the Google Ads Service.mutate method efficiently, we probably need another feature, which is a temporary ID, which is a placeholder for forward references in your operations, like when you want to link campaign budget and campaign together in one request. Please check out a simple model for mutates for more details. To have a quick review of the temporary IDs, again, they are placeholders for forward references, and they are a unique negative number across resource types. Like shown on the slide here, we are trying to create a campaign. Usually when we create a new campaign using a single resource service, we would not want to specify any resource name because that will be created by the Google Ads API. But here we are using the Google Ads Service.mutate, so we need to specify the resource name using the temporary ID as -1. Then in the ad group operation, where we want to create a new ad group, we can link the ad group to the campaign by specifying the campaign resource name using the temporary ID -1 that we used before. The temporary IDs will be assigned the real IDs by the Google Ads API server when you send this request to the server. Note that the -1 number here is hard-coded for the sake of simplicity, but in the real-world situation, you may want to use a kind of tracking function to handle decreasing the negative numbers for you. So what if you have so many resources to mutate? A single Google Ads Service.mutate request can contain up to only 5,000 operations. Beyond that, you might suffer the issue that we mentioned before, the orphaned resources issue. In this case, you should use batch processing to help you because it runs operations in parallel and allows up to 1 million operations per batch job. You are also allowed up to 100 active or pending jobs at one time. Batch processing automatically retries any transient errors that might occur on the server side. You are allowed to use the temporary IDs the same way as you use with the Google Ads Service.mutate. However, don't submit multiple operations that mutate the same object in the same job, because the order is not guaranteed, and you may end up with the undeterministic result. Next is about response content type that I already mentioned before. The response content type field determines the mutate response. Again, the default behavior is equal to when you specify the response content type as resource name only. It will return only the resource name of the mutated entity. This is very efficient because it contains very low overhead. But if you specify the response content type as mutable resource, it will return resource name together with the mutable fields. The response will contain all the mutable fields suitable for further mutates, like when you want to modify the objects returned by the API for your job, then using the mutable resource response content type will save you the time for issue another search or search stream requests. However, only mutable fields that you modified will be returned. So if a field is not returned, because that field is not mutable or that field isn't modified in your previous request. To get the remaining fields, including non-mutable fields, issue a search or search stream request and specify your desired fields in the query. The final feature I would like to mention for mutates is mutate validation. In many services, they provide an optional validate-only parameter for their requests. You can use this to test whether your operations will succeed or fail. Like, it's particularly useful for when you want to test policy validations of an app. This improves chances of success, but it does not guarantee that the results will be the same, because the downstream business logic may cause an error during the real execution. And the third topic of this presentation is excelling at Google Ads query language queries, or Goku queries. First, what happened to select star? Google intentionally does not support select star in our language because retrieving all the columns and metrics is very expensive, and this is the exact same reason why we do not allow get method to be more than 1,000 requests per day for each developer. Instead, please explicitly specify the fields that you want to retrieve, and if you do not know what fields are supported for a certain resource, please check with the references of our developer websites. Alternatively, you can use the Google Ads Field service to fetch the list of fields available for the report you are requesting. Next, please use the where clause effectively to filter only what's necessary for you. This can be either the date range, or the status of the resources, or any properties of the resources. By default, resources are returned even if they have been removed, so most of the time you may want to add the condition to filter out removed entities, like where resource.status not equal to removed. Next is about the date range. Select a reasonable date range or use a predefined one to just scope down into the date range that you want. Like you can use segments.date during last business week. Finally, you can use not in or in to narrow results to the desired subset. Like, for example, we want to retrieve only search and display campaigns, then we can use where advertising channel type in search and content. Next is about limit and order by. The Goku language permits multiple ordering subclasses, so you can use order by one field, comma, another field, like order by ad group ID, followed by campaign ID. In this way, you can sort the result based on the ad group ID first, and then followed by the campaign ID. When combining this with limit, you can achieve precise reporting very easily. Let's see some examples. The first example is to find the top 5 impressions dates in the last 30 days. We can specify two fields here, segments.date and metrics.impressions. In the from clause, we select ad group here, but actually you can select other resources if you want. In the where clause, because we want just only last 30 days, we can use the predefined date range, segments.date during last 30 days. Finally, we want to get the top 5 impressions, so we order the metrics.impressions in descending order and limit the result by 5. The other example is to find the most expensive ad groups with a low click-through rate, or CTR. Here we select 3 fields, adgroup.id, metrics.costmicros, and segments.adNetworkType. Again, we use the resource of ad group. We have 3 conditions in the where clause. Metrics.ctr less than a threshold, highlighted in purple here, meaning that you need to specify the number by yourself because the definition of being a low click-through rate might differ between people. The second condition is the ad group.status not equal to removed. Again, we might not want all the entities or the resources that are already removed. So we need to filter out them here so that we get a little bit smaller set of results. Finally, the third condition is segments.addNetworkType in content and search. This is to limit our ad groups to only those belonging to the search and display campaigns. Finally, we order metrics.caught_micros in descending order in order to get the most expensive ad groups, which by definition here, it is the ad groups that have highest cost in micros. Finally, we limit the number here to 10. Actually, it can be any number, but in our example here, it's 10. Next topic is about segmentation. Segmentation occurs when you add either of the following to your query. Segments.fieldName, which is either fields of the segment's resource, such as segments.date, or a field of segmenting resources, such as when you add any fields of the ad group resource when the feed item is in the from clause of the query. The Google Ads API allows segmentation of more than one field, which is unlike the UI, because the UI allows only one at a time. However, number of rows can increase exponentially for each additional segment, so please beware not to add too many segments to your query in case you have a lot of properties and a lot of rows that you want to fetch already. Not all segments and metrics can be selected together, and you can check that information from the selectable width section of each entity in our references. Finally, the resource specified in the from clause always segment the report, and that's why even if you do not specify resource name explicitly in your query, it still will be returned and also segments your report. There are some special rules for segmentation. The first one is about the coordinate segments, composed of date, week, month, quarter, and year. They behave a bit differently from other segment fields in some situations. The first situation is when a segment is in the where clause. It must also be in the select clause, except for these coordinate segments. Let's take a look at some examples. The first one is select adgroup.id from adgroup where segments.date equal to the specified date. This one is valid. But the other one, select adgroup.id from adgroup where segments.addNetworkType equal to search, is invalid. The reason is, for the second example, segments.addNetworkType is not a coordinate segment. So when it appears in the where clause, it must also be in the select clause too. The other situation is that if any of the coordinate segments are in the select clause, a valid finite date range composed of the coordinate segments must be specified in the where clause. Note that, however, the coordinate segments in the latter part that I mentioned do not need to be the same one as appearing in the select clause. Let's take a look at some examples. The first one, select segments.week from adgroup where segments.date during today. This one is a valid one because although segments.week does not appear in the where clause, we have segments.date defines a valid finite date range for us. The second example, select segments.week from adgroup where segments.date during today and segments.date during last month. This one is not a valid one because although we have segments.date during today and segments.date during last month, each defines a valid finite date range, combining together results in non-overlapping range. So this where clause does not define a valid finite date range for us. And that's why this query altogether is not a valid query. Another rule for segmentation is that some views are implicitly segmented by more than one token of the resource name. For example, search term view is segmented by ad group and a search term. This is actually reflected by its resource name, such as customer/123/search term views /111 tilde ad group ID tilde and a search term. This is true when the last token of the resource name, such as the search term in this case, is not globally unique. Visit the section that I link in the slide to check the uniqueness of other object IDs for more information. I would like to introduce you to some useful tools that our team created. The first one is Google Ads Query Builder, which is available for all resources. You can select from the available fields interactively, and the tool will automatically validate the syntax for you and will guide you through all the rules, like segmentation rules that I mentioned before, and show warning messages when you violate those rules. Alternatively, you can also access it from each reference doc, like for the case of the ad group, like it's shown on the slide. There will be a button below the title of each reference. The other tool is Google Ads Query Validator. In case you have a query already and you just want to check whether the query is valid or not, you can use this tool. You just need to type or copy and paste your Google query in the text box shown on the screen. Don't forget to check any limitations that the tool has as well, and the result will be shown below the text box. If the query is invalid, suggestion for the fix will also be shown to you. If not, there will be a green sign and you are good to go. And that's all for this session. Before I end this presentation, I would like to introduce you to some useful resources. The first on the list is the homepage to our Google Ads API developer website. Apart from that, I also include some relevant guides such as mutate best practices, segmentation, and so on. Feel free to check them when you have time. And as a reminder, we have a Q&A forum located below this video. Feel free to submit any questions you have. Our team is standing by to answer them. And if you need any help after this workshop, reach out to us via the dedicated support channels shown on the screen. Thank you for watching.